In this video, see if you can practice making a drawing and speaking an explanation of why the different formulas work. Explain what circumference and perimeter are using these two figures. Pause the video and see what kind of language you would expect students to use. We want students to understand that the word para means around. So perimeter means we're going to start at one point and measure the distance completely around an object. While there are formulas for this, each shape is different, so having students just understand that they're adding up all the sides makes sense. Circumference is perimeter in a way, except it's the distance around the outside of a circle, because circ means circle. How do we find that distance? We know that the distance across a circle through its center point, the diameter, will fit around the outside of a circle, 1, 2, 3, and a little bit more. So if we call the distance across the circle d for diameter, that 3 and a little bit more is pi. So the formula for this is pi times d. Or we could say pi times 2r if we looked at just the radius. We would need 2 of those. And then if we had 2 of those, that would also go around the outside 3 and a little bit more. What are the formulas for finding the area of a square, a rectangle, and a parallelogram? See if you can explain it in your own words and use the drawings. When we find area, we're covering a square. We're covering what we're looking at. So what we're actually doing is covering this shape with units that are the same size, square units. So what we have to figure out is how many of those would there be in each row and how many rows would there be. In a square, the sides are all the same size. So S would be how many squares it would take to make a row across. And if we took that times S again, that would tell us how many of those rows we need. S times S is the same as S squared. So the area formula for a square is sides squared. The area of a rectangle is exactly the same concept, the same idea. We're figuring out how many of those square units it would take to cover the rectangle. But in this case, the sides are not the same size. So we have to figure out how many there are in a row and then how many of those rows we have. So that would be taking one side times the other side. That is often length times width, or sometimes people even say base times height. Finding the area of a parallelogram is really no different. What we're kind of doing here is we're making a little cut right here, and we're going to move this triangle over here so that we actually have a rectangle. And once we do that, we can use exactly the same idea that we had with the rectangle. The formula is the same. So this time, what we have is base times height. And we have to make sure we understand that height is not the same as this side. Base times height. What are the formulas for finding the area of a triangle, a circle, and a trapezoid? And how would you explain why they work? Pause the video and see what you think. The area of a triangle is going to have 1/2 of the area of a rectangle that we could build around it. So the area of a triangle is 1/2 of the base times height. If we use base times height for a rectangle, then the triangle will take up half the space. 1/2 of the base times the height. In a circle, the formula is pi r squared. Why does that work? If we have r and we make a square out of r, that looks like that. If we took 4 of those squares, that would be 4 times r squared. But we don't take it times 4 because we don't want these corners. We have to chop off those corners. And pi is the magic number that does that for us. So instead of taking the radius squared, which is this, times 1, 2, 3, 4, we're taking the radius squared times 3.14. So what pi does for us is chop off those corners. The formula for finding the area of a trapezoid is base 1 plus base 2 times the height divided by 2. Now, why does that work? If we take another trapezoid just like this one, but we tip it upside down and we attach it over here, we now have a bigger parallelogram. So if we look at the entire figure here, we have a parallelogram, and we know how to find the area of that. It's base times height. So how would we find this base? That would actually be taking the original base that was here and adding it to this base, the base of the flipped one, which is of course the same as that top base. So if we take base 1, that's right here, plus base 2, that's right here, times the height, because that's how we find the area of a parallelogram, then of course what we have to do is divide it by 2, because we don't want the area of this entire parallelogram. We only want half of it. We only want the trapezoid. So that's why the formula works. Here are the formulas for finding surface area of a cube, rectangular prism, and a cylinder. Pause the video and see if you could explain why the formulas work. To find the surface area of a cube, we need to find the area of one side and then add how many sides there are. In a cube, the sides are all the same. So to find the area of one side, we know that we take length times width. But since the sides are the same, that would be like the side squared. Side squared gives us one side, and then we know we have to count how many of those we have. We have 1, 2, 3 around the back here, and 4 over here, and then we have a top, that would be 5, and then we have a bottom, that would be 6. So there are 6 sides, so the formula is side squared times 6. For a rectangular prism, we're using the same idea, except the sides are not the same. So we have to find the surface area by finding the area of each of the sides. So for example, we can find the area of this side by taking the length times the height. Length times height. We can find the area of this side by taking the width times the height. Width times height. And we can find the area of the top by taking the width times the length. Width times the length. That would give us the area of each of these sides. But we know that we actually have 2 of each of those. We have this and the one on the back that will be the same. We have this and the one over on the end, which will be the same. And we have this and the one on the bottom, which will be the same. So we have to take each one of those times 2. Basically, we're finding the area of each of the sides and adding them all together. To find the surface area of a cylinder, we need to think of it in 2 different steps. First, we need to think about finding the area of the top and the bottom. To find the area of that circle, we know that we say pi r squared. Pi r squared will give us the area of 1, either the top or the bottom. So we're going to have to take that pi r squared times 2 to get the top and the bottom. Now we need to find the surface area of this part that goes around. To do that, we need to know the distance around, so that if we unfolded it, we would know what this distance would be, and then the height. We know that to find the distance around a circle, we take 2 pi times the radius, or pi times the diameter. And if we take that, it will give us this distance. And then we need to take that times the height. so that we know how much space there is in this part that goes all the way around to the other side. So basically what we're doing is we're adding the body of the cylinder, that surface area, to the top and the bottom. So the formula is actually in two parts. We can think of it as 2 pi r times the height plus pi r squared. We want students to think about surface area as a logical thing, as a reasonable idea. We're covering the surface. It's like we're gift wrapping something. How much would it take to cover the sides, whatever those sides are? How do you find the volume of a cube, a rectangular prism, and a pyramid? Pause the video and see if you can think about what the formulas are and explain why they work. To find the volume of a cube, we need to find the area of the base, or one of the sides. If we find the area of this, that would tell us how many units it would take to cover the bottom. Then we need to know how many rows of those it would take to absolutely fill the cube. So to get the area of the bottom, the base, we're taking the side squared because the sides are all the same size. We're taking that times the side again because the height is the same as all the other sides. They're all the same length. So basically we're taking the side times the side, which is the side cubed. That's how we find the volume of a cube. The concept for finding the volume of a rectangular prism is very, very similar, except that the sides aren't the same. So if we find the area of the bottom, we can do that by taking length times width. That will tell us how many units it would take to cover the bottom. Then we need to take that times height to figure out how many of those layers we would need to fill the rectangular prism. Length times width times height. We're actually going to do that very same thing to find the volume of a pyramid, except that there's one slight difference at the end. If we draw a rectangular prism around our pyramid and just think of that entire shape, then we can do this the same way we did this. We can take the area of the base, length times width, and we can take it times the height, and that gives us the volume of this entire shape. But we don't want the volume of the entire shape, we only want the pyramid. We know by work we've done in the past that the volume of a pyramid is only a third of the volume of that whole shape. If we filled this pyramid with water and dumped it in this rectangular prism, we would have to do that 3 times to fill it up. So if we know the volume of the rectangular prism, we can divide that by 3 to get the volume of the pyramid. So the formula for the volume of a pyramid is length times width times height divided by 3. What are the formulas for finding the volume of a cylinder, cone, and sphere? And how would you explain why they work? Pause the video and see what you think. To find the volume of a cylinder, we need to find the area of the bottom, how much it would take to cover the bottom, and then the height so that we can fill that cylinder. We know that finding the area of a circle is pi r squared. That would give us the area of the bottom. So to get the volume, we need to take that times height. And that will give us the volume of the entire cylinder, what it would take to fill the cylinder. The volume of a cone is actually very similar. We know that if we built a cylinder around this cone, it would take 3 of the cones to fill the cylinder. So if we find the volume of the cylinder, just like we did here, pi r squared, that's the base, times the height, that will give us the volume of the entire cylinder. But we know that the cone only takes up a third of that space. So we need to divide that by 3 to get the volume of just the cone. To find the volume of a sphere, we need to think about it inside a cube. To find the volume of a cube, we take the side cubed. But finding the volume of the sphere is a little different. We need to think about starting at the center of the sphere. And we're thinking about creating a radius cubed. If we do a radius cubed, we would get this little cube right here. If we did that to fill the whole sphere, there would be 4 of those on the top row, and there would be another 4 of those on the bottom row. So we would have 8 of those little cubes. That would fill up the entire bigger cube. What we know, however, about a sphere is that it takes up less than half of that space. Less than half, even though it doesn't seem like that. If we filled the sphere and filled the cube, we would find out that it takes up less than half of that space. So to find the volume of the sphere, we're going to take the radius cubed times 4/3 pi. 4/3 pi times the radius cubed. The radius cubed is this part right here, and 4/3 pi is going to get us to a little less than half. It's going to be between 4 and 5. So what that does for us is cut off all the corners and all that extra space that's around that sphere that we don't want. That one's complex. What is the formula for the Pythagorean theorem, and why does it work? Pause the video and see if you can draw and explain this formula, and then see if your ideas match mine. The formula for the Pythagorean theorem is a squared plus b squared equals c squared. So if we call this side a, this side b, and this side c, what it means is if we make a square out of a and a square out of b, and we add the area of those two squares together, that will give us the area of a square made out of c. That's just a rule of nature, a mathematical law. So to find this area, we have a squared. To find this area, we have b squared. And if we add those two together, we will get c squared. So if we want to know what c is, we would have to take the square root of c. We would find this area and then figure out what times itself would give us that area. And that would be the measure of c. Here you can see the formula for finding slope. Why does that formula work? What does it represent? See if you can explain, and then see if your thinking matches mine after you pause the video. I'm going to put 2 points on this line. First, 3, 2. So my coordinates are 3 on the x-axis, 2 on the y. There's my point. My next point is -2, -2. -1, -2, -1, -2. If I draw a line connecting those 2 points, I can see my slope. Now if I apply the formula to what I have here, I would have y2 minus y1. y2, that's -2, minus y1, which is 2, over x2, which is -2, minus x1, which is 3. -2 minus 2 is -4. -2 minus 3 is -5. What that tells me is this. The -4 tells me the range that I have on the y-axis. So I have a range between my 2 points of 1, 2, 3, 4. On my x-axis, I have a range of -5. 1, 2, 3, 4, 5. So my distance this way is 5. My distance this way is 4. If I start with the second ordered pair, I am going negative in both directions. Two negatives means that my line is going to have a positive slope. So -4 over -5 is a positive slope, which means it is increasing as it goes. Slope is used for a lot of practical things in the world, so we need to make sure that students understand that before they get into this kind of work. And if they don't understand this kind of thing at the elementary level, I'm really okay with that. I want them to know what slope is and what it's used for.